Hello, today we're going to be talking about the national grid. The national grid transfers electrical power from power stations to consumers, and it's made up of a system of cables and transformers. So we're talking about these bits here in the middle. These are my transformers and these wires are the cables that connect them. Now, if you know anything about the national grid, you'll know that these power lines have a high voltage running through them. So why is that? Well, here on this piece of equipment, I can change the voltage. I can either have low voltage or high voltage. So let's first investigate what happens when I put a low voltage supply through the national grid. Well, my light bulb's turned on, but what happens when I change this to the high voltage supply? Well, first of all, we can see that my light bulb is brighter, but nothing else has really changed. So we need to change how we're looking at it. This is the same setup, but this time we're viewing it through an infrared camera. You can see that as the current flows through the wires, it heats up. Let's compare the low voltage with the high voltage. What do you notice? The low voltage heats up much faster than the high voltage. So why is that? This is where we need to bring an equation back into the picture. We know that power equals potential difference times current. So therefore, if we're transferring the same amount of power, what happens when we change the potential difference? If I start to increase the potential difference, then you can see that the current starts to get smaller. If the current is smaller, then less energy is transferred to the surroundings, which makes the system much more efficient. So therefore, by having a high potential difference, we're transferring the energy more efficiently, losing less to the surroundings and getting more to the consumer. This is especially important over the long distances that the power has to travel. So what happens when it gets to the consumer? Well, that's where we need to use a transformer. A transformer is basically two coils of wire wrapped around a magnetic core. The ratio of coil numbers on either side determines what type of transformer it is. Here at the consumer end, we need to lower the voltage, so we use what's called a step-down transformer. This has more coils of wire on the primary coil than it does on the secondary coil. And this will step the voltage down to the 230 volts that we use in a domestic setting. Over on this side, we need to increase the potential difference. So therefore, we're going to use a step-up transformer. A step-up transformer has more coils on the primary coil than on the secondary coil, and it's basically a reverse of our step-down transformer. These can increase the voltage in this system anywhere from around about 25,000 volts to 400,000 volts. So there you go, that's our video on transformers and the national grid. Make sure you subscribe, hit the like button and check out our other videos on electricity for more revising science. Happy sciencing!